This is Nitin Darhad, and I'm here today at the Institute of Directors in London, in the UK, for the Silicon Catalyst ChipStart U.K. event. And we had a quite an interesting day where we had Cohort 1, which was launched about 8 or 9 months ago, of the ChipStart U.K. program, the incubator program, presenting at the end of the program almost. I think Sean Redmond said they've sort of got around £7 million worth of investment over the last 8 months. And so now they, I suppose, graduate from the program. And we had presentations from the Cohort 2, which is coming in now. In this piece here, you'll hear interviews from Sean Redmond, and he'll talk about some of the breadth of the innovation and the companies and the program. And then I also managed to speak to Jamie Urquhart, who is one of the co-founders of ARM, but also is one of the mentors here at the ChipStart UK program. In the final piece, you'll hear my conversation with David Harold, who, like me, has been around in the UK electronics industry for a while, and he's now currently an analyst with John Petty Research, but also an advisor to various companies. So let's hear from Sean Redmond. I managed to get Sean Redmond, who's the managing partner at Silicon Catalyst UK. Sean, hello.
Hello, Nitin.
We're at the Institute of Directors and the ChipStart UK event. This is the presentations from the first cohort, but also we had some interesting presentations. But tell me some of the sort of objectives and the thoughts about what's happening here. I know we spoke when you launched, was it 9 months ago or a year ago?
It's been just 8 months of the first cohort of ChipStart UK. Those UK semiconductor startups have raised over £7 million of private VC and angel funding already. 9 months of incubation, so they've got 1 month to go. We train them with semiconductor industry-specific courses, go-to-market, IP strategy, how to negotiate their EDA contracts, their term sheets. We've now selected the second cohort of ChipStart UK. This second cohort will be onboarded in July, and they've got 9 months of incubation with us where they get access to the full Silicon Catalyst ecosystem. That's access to free EDA tools, free design IP. They can tape out to advanced node semiconductor foundries like TSMC through that 9 months at no cost. They get access to our advisor base. We assign a mentor from the advisors that will chaperone them through the 9 months with weekly touch points. And they get access to the investor relations. We track and introduce them to the right investment at the right time.
Yep. Now, today I think there's more than just the startups. I mean, we had the venture, the angel activities. Can you just quickly summarize those? Because I know that there's one, obviously the big one in the US. You were in the Santa Clara last week, and then there's the one with Neil Dickens with IC Resources as well.
A lot happening in Silicon Catalyst. So we have launched Silicon Catalyst Ventures out of the US. This is a new fund that Silicon Catalyst startup companies through our 2-year program will get investment through our Silicon Catalyst Venture Fund. We also, in the UK, have replicated the success of Silicon Catalyst Angels, focused on US startups, in the UK to bring a Silicon Catalyst UK angel group together. Tremendous support from the community here. It means UK-based semiconductor startups can get a semiconductor-focused angel group to pitch to and get that early stage investment.
There's quite a buzz here, and I think one of the things I'm quite relieved about is after being at Computex in Taipei, and everything is about AI, but actually, even though the stuff here is about addressing some of those issues, nobody mentioned, apart from a couple of companies at the end on Cohort 2, there's a real sort of things about data movement, about different architectures, and there's real sort of excitement about figuring out how to spin out research and new architectures, new materials, with photonics, with compute and memory and all that kind of stuff.
Was the fundamental objective of Silicon Catalyst ChipStart UK program was to reach deep into the UK semiconductor research base. We've got the third largest semiconductor research base in the world, yet we don't commercialize those opportunities well enough. So we wanted to create a path, 9 months of fast-track innovation and incubation to take semiconductor research groups into scalable global semiconductor startup companies. And it's not just about AI, right? You look at where we need to take the 3 to 5 orders of magnitude of performance that the semiconductor industry has to deliver to meet the requirements that are in the demand cycle out there. It will come from compound semiconductors, it will come from metamaterials, it will come from nanomaterials, it will come from new AI architectures, but all sorts of new types of approaches to semiconductors, from packaging to materials, and in fact new types of ways of delivering semiconductor implemented circuits.
Well, Sean, I know you have to go and introduce our next mega speaker, Stan Boland, but thank you very much.
Thank you, Nitin, an absolute pleasure.
I've managed to grab hold of Jamie Urquhart, who's the co-founder, who's one of the co-founders of ARM. Hello, Jamie.
Hi, Nitin. How are you?
I'm fine, thank you. But here, Jamie is actually quite a prominent mentor at the ChipStart U.K. program with Silicon Catalyst. Well, he's one of several mentors. Jamie, tell me a little bit about you getting involved in this.
So I got into the electronics industry back in 1980. I joined a company called Plessey, who are able to offer state-of-the-art designs at that time. And I'm sad to say I've seen the industry sort of decline over the last 40 years. We've had some successes. It's not been all doom and gloom. But what I'm really pleased about is the ChipStart is bringing some more energy and awareness and getting a whole load of people together who want to put something back, which is really good.
And so you're mentoring one of the companies in the first cohort. Just tell us about your journey with that.
Yeah, so I'm mentoring HyperSim, and it's a very interesting company. They've also been working with DSV, Deep Science Ventures, to help them get started. And it's been a very interesting journey. And you see a lot of change as you go through the program. I've listened to most of the things they've been taught. I've enjoyed it. I've learned a few things as well. But it's been a tremendous journey. Very fast-paced, and I think some of the time they probably think, why am I learning this? And then later on realize something's there. And I hope we're not sugarcoating it. It's hard work starting up a company. And it's great, and it's great to see that progression.
And HyperSim, I think one of the things I was impressed with the presentations this morning from the first cohort was just how they're trying to tackle those compute architectures. You know, we're all getting power hungry with the data center stuff, but everything I've heard this morning is all around figuring out how to innovate and change that so that we're not going just on one path, but whatever we're doing right now.
Well, as you know, the Moore's law has doubled the complexity, and it's produced some massive changes in terms of the what we do. But we humans are capable of sort of blindly stumbling into a situation where we need massive amounts more power. We've got climate change. And I think one of the things about today's younger startup people is they're interested in world issues that have factors. And so they're tackling some of these things that we're stumbling into, basically. So it's good to see. But we're always going to be very hungry for power, computing power, that is.
Yep. Now, Jamie, what keeps you going? Because you've been quite a long time in the industry. You retired, maybe retired a few times. But what keeps you going? Why still do this?
Why did I get up at 5 o'clock this morning in order to be here? Yeah. I enjoy it. Yeah. Main thing, I feel I've been very lucky. Yes, ARM has been very successful. Yes, it was a lot of hard work, but it was also right place, right time. And I'm grateful that I've been able to do this. And so I'm just putting a little bit back into what I do. I've stopped angel investing. I was a VC. But this way I still get a lot of contact with some really interesting people with really interesting ideas. And I hope that they benefit from the help we can give.
Well, Jamie, thank you very much.
Thank you.
Well, one of the people here at the ChipStart UK event is David Harold, and David he's been writing a lot with companies like John Petty Research, the analyst firm, but also consults and advises to various firms, and previously spent a lot of time with Imagination Technologies. David, hello.
Hello.
So, putting your independent hat on, It's been quite interesting here. I mean, I've seen quite a lot of innovative stuff this morning with the ChipStart Cohort 1 presentations, and also some interesting ones with the Cohort 2. What's your analysis? Put your analyst hat on.
I think it's really interesting actually to see the range of technologies that are here. It's not just people tackling one problem. We've got everything from POM, who are doing a sort of biosensor, very much focused on women. We've got people who are tackling vision problems. We've got people who are tackling really fundamental problems about, how do we get beyond the scaling issues with Moore's law, etc. I think that breadth of things is really interesting for the UK. Software companies, silicon software companies. Everything is in there.
Yeah, I mean, I was fascinated because obviously I was just at Computex in Taipei, and everything was about big AI and maybe some little AI as well. Yeah. But here, I think what I was seeing was, apart from a couple of presentations, nobody really talked about AI. They talked about data movement, they talked about computed memory, they talked about nanomaterials. Yeah. So, I mean, it was quite a refreshing change, wasn't it?
Well, that's the thing. I think it's not any kind of secret to say that if you're Intel or if you're NVIDIA, right now you are considering how do you get beyond the limitations of the technologies you currently have. Okay, you're down at 2 nanometer, you've pushed the processes as far as you can, you're doing interesting packaging, you're putting memory, in new places, but at some point you have to do something much bolder and much bigger than that. And these companies are already in that space. They don't have any legacy. So it was interesting how much was optics, how much was silicon photonics. They've been around for a while. How much now is, nanomaterials, metamaterials was a topic that came up a few times. Yeah. So, I think that is actually really interesting because it's the people who are solving those problems now who are going to be on the radar of Intel, NVIDIA, whoever down the line, and help them solve their big problems.
Well, I mean, the worry is one of them will obviously be gobbled up by one of these. But coming away from that M&A type of scenario, yeah. The interesting thing I thought, a couple of presentations around chiplets, and then the optics, optical, free optical communications, reducing energy was one of a big topic. But also, I think the EDA tools for optical optical semiconductors integration. But that's quite fascinating that we're seeing all of this, because I think when I was in San Diego with the OFC panel, I think one of the things people talked about was there wasn't enough EDA for optical integration.
I think there's really interesting stuff going on around tools and EDA, and I mean, you and I have been around long enough that we've seen several people who come along with a tool that say it's just going to generate your chip for you. Yeah. And it's
told that story a few times.
I mean, it never has. It's never that credible. But actually, some of the stuff that's going on with AI, so long as you understand the parameters, okay, it's going to come up with something, then you've got verification issues and whatever else still needs to be done. But actually you are getting closer to some really interesting automations with tools that are coming through, EDA tools that can extract IP from pre-existing design, for example, and say, actually, maybe this is what an IP product might look like based on this. So I think there's some really interesting stuff going on there, and you're right. The tools that allow you to work with these new kinds of chips, whether they're optical or metamaterial based, are definitely going to be important. Somebody is going to build a business on that, and you're probably right that at some point it will then get gobbled up by a much bigger player, which in some ways is a bit of the curse of these kinds of things. The two really interesting sort of at the coffee table discussions that I've heard here have been about how do we scale really big businesses for UK PLC, and I think there's some real government commitment from that. I think it's going to transfer over to the next government, so I feel kind of positive. But also, I talked to quite a few different VCs who were here, who are saying, maybe what we need to do to get together to crack the lack of investment in semiconductors is we're going to form a semiconductor fund. And there are a few kind of people just batting that idea around, which I felt pretty good about.
Well, that's good. I mean, my key takeaway here is novel computer architectures and switching and EDA tools for optics, but there are lots of others.
Yes, absolutely. And really a fundamental thing that came up from the organizers, Silicon Catalyst, ChipStart, is how many of these companies are looking to get over pretty fundamental barriers in terms of scaling, performance, and power. I think that that's important. You can build a big company on that.
Well, David, thank you very much.
Thank you. It's great.